Welcome to Marilakshman Reddy Institute of Technology and Management. I will be discussing antennas and wave propagation. Okay, in lecture 6, we will be discussing about wave tilt, refractive index of ionosphere derivation, and a few previously asked questions. Okay, so as part of syllabus, we almost covered everything. So if anything is not completed, we'll discuss in the next classes. Okay. So today we'll be covering these questions. Wave tilt again I'll be explaining because very important, asked many times. And what are the types of ground wave, and what are the factors that affect the propagation of radio waves, and what is wave tilt. If they ask you list all the factors also, I'll tell that factors which are affecting the wave tilt, and expression for refractive index of ionosphere. This is very important. So today this derivation we'll be discussing in detail. Okay, now let's go to wave tilt as we all discussed previously. So wave tilt is nothing but the change of orientation of vertically polarized ground wave. So why it is vertically polarized only? Because if it is horizontally polarized, since it is ground wave, it will pass through the surface, and due to the induced signal by the earth, it will be attenuated at a particular distance. So the ground wave propagation should be done by using only vertical polarization. What is vertical polarization? If you all remember, if electric field is perpendicular to the propagation of signal, then it is called vertical polarization. Okay, then so this occurs mainly due to diffraction, and due to this tilt, the horizontal and vertical components of electric field and will be not in phase and will be in out of phase. Okay, this tilt will change the vertically polarized wave into elliptically polarized wave, because when it is polarizing vertically, since the obstacle is coming in the picture, so it will move along the obstacle, because frequency is less frequency is more wavelength, right? More wavelength means it can tilt along the obstacle. So that is what wave tilt is. And as the wave progresses, as we discussed, due to the induced wave by the earth, the wave will get attenuated. So this results in very high power dissipation. Okay, so what is the angle of tilt? So we can see here. So if it is propagating in this direction, and if it is moving the direction from this angle to some other angle after getting some obstacles in the middle, then that is called wave tilt, and it is represented by theta here, you can see. Next, so what are the factors that affecting the wave tilt are permittivity and conductivity. These two factors will be affecting the wave tilt. If they ask you the question, you have to write these two conditions. Okay, so what are the types of ground waves? So they asked you types of ground waves, right? So there are two types of ground waves, generally Rayleigh waves and love waves. So what are Rayleigh waves? They are also called as ground waves, ground roll, okay, which spreads like a ripple, which we will see in oceans generally. So these Rayleigh waves will move both in vertical as well as horizontal direction. Okay, so like this in figure you can see there will be both horizontal waves and vertical waves, whereas love waves will be only horizontal. Okay, these Rayleigh waves will be 10% slower than the seismic waves, which we see generally on the above the surface of the earth, which are generated below the earth. Okay, these seismic waves will be faster than Rayleigh waves. Rayleigh waves will be 10% slower. Okay. So love waves, another type of ground waves is love waves. These are same as seismic waves, okay, but with vertical displacement. Seismic waves, how they are generated in the opposite direction, the love waves will be generated, but only in horizontal direction, okay, which we have discussed already, okay, and which will be right angles to the direction of propagation, okay, only one direction, and they will be right angle to the direction of propagation. And the coming to the speed, it will be little speeder than Rayleigh waves, but 10% slower than seismic waves only, okay. Hence seismic waves are the fastest waves which are generated below the earth, and these love waves cannot spread through the water because only one direction they are able to move. In water, if they want to move, it should have both the directions, okay. Then what are the factors that affect the propagation of radio waves is another question, 2 marks or 3 marks question. And for this question you can answer like the 3 factors that affect the propagation of radio waves are spherical shape of the Earth's atmosphere and interaction with the objects on the ground. The objects which are coming in the picture in when a wave is traveling along the surface or along the path of the electromagnetic wave, okay. So in short, we can say electromagnetic radiation affected by phenomena of reflection, refraction, diffraction, absorption, polarization, and scattering. So these all factors will be affecting the electromagnetic radiation, okay. So we have already seen this problem, okay, which after substituting all the constants we'll be getting another formula, right? So this formula, how it has been derived, we'll be seeing now. This is the question asked in the previous question papers. So what is the expression for the refractive index of the ionosphere, or it may be also asked as propagation of radio waves through the ionosphere. They may ask anything like this, okay. So coming to this, when radio waves passes through ionosphere, what happens? Actually, what is happening in the ionosphere, as we discussed, the sun rays, UV rays, cosmic rays falling on the atoms makes it ions by leaving the electrons outside, right? We have discussed in skywave propagation previously. So that ions and electrons released will have some charge, right? So when radio waves are hitting these electrons and ions which are present in ionosphere, makes them to move, okay, makes these charged particles to get into motion, okay. They will be moved by this radio waves when radio waves are transferred into the atmosphere. Since the mass of ions is very high when you compare with electrons, the weight of the ions will be very high when compared with electrons. That's why when radio waves hit the ions also, they will not move at all, okay. It is very less motion. That's why we'll treat the movement of ions as negligible, okay. And we will consider only electric field of radio waves making electrons to move here and there, and due to which there will be some vibration occurring which is parallel to the electric field of the radio waves or electromagnetic waves. I repeat, when radio waves hit the electrons and ions in the ionization layer, ions will be not moved much because of their high mass or high weight. Therefore, that movement is taken as negligible, whereas motion of electrons is considered as primary part, and they will be vibrating. Due to this vibration, there will be an AC current which is proportional to the velocity of vibration. Okay, so these electrons will be moving in parallel with the electric field of the radio waves. Okay, so but effect of magnetic field of Earth. So the magnetic field which is having in the Earth makes these vibrated electrons lag behind the electric field. Thus electron current is inductive. What happens? Electron current will be becoming inductive because the magnetic field which is generated by Earth is making these electrons which are moved in the ionosphere, okay, lagging behind. So if they are lagging behind, the electric current, electrons generated current will become inductive. We'll see that in the derivation. Okay, so the actual current consists of both capacitive current and electron current. Capacitive current will be leading the voltage by 90 degrees, and electron current lags the voltage by 90 degrees. Okay, electron current is lagging, right? Then so these free electrons, what happens? Decreases the current, and the dielectric constant also will be decreased. What is dielectric constant? K. K value will be decreased. Okay, when you don't have an electron, if you consider dielectric constant as 1, okay, the dielectric constant will be reduced below 1 if it is having electron in the ionization layer. Okay, so this reduction in the dielectric constant, okay, due to presence of electrons in the ionosphere, makes the path of radio waves to bend towards Earth. So that is why we are getting the wave reflected back to Earth. Okay, you understand? Hope you understand. Okay, so this is how the wave which is traveling into the ionosphere is bending towards the Earth again. Okay, so which is nothing but from high electron density to lower electron density. In ionization layer, you will be having more number of electrons due to cosmic rays. The atoms releases more number of electrons. So let us take an electric field as E equal to Em sin omega t. What is Em? Maximum amplitude of the signal, and omega is 2 pi f, angular velocity. So which will be in volts per meter. Okay, force exerted by electric field on each electron, okay, will be taken as force equal to minus EE. So what is small e here? It is the charge of an electron in coulombs, and capital E is electric field. Okay, and negative because negative electric field. Okay, we will be getting lagging, right? So that's why. And let us assume there will be no collision. Primarily, there is no collision with the electrons in the ionosphere. Then the velocity, which will be opposite to the field, direction opposite to the field. Okay, then F is nothing but mass into acceleration. If there is no collision, we have to take F equal to mass into acceleration, where F is minus E into E, capital E, from here to here. Okay, and mass is m, mass of electron. Okay, acceleration is nothing but rate of change of velocity. Okay, dv by dt. And if we compare dv by dt equal to, so if minus ee goes to the other side, it becomes minus ee by m, or simply dv you can take it as minus ee by m into dt. If you integrate on both sides, what happens? Integration and derivation will be cancelled. V will be left, velocity equals to integral E by m is constant, take out and write E as Em sin omega t dt, and Em is amplitude, which is constant, again we can take out. So integral of sin omega t is minus cos omega t. Then this minus and that minus will be cancelled. So you will be getting E by m into omega into em cos omega t. Cos omega t by omega, right? When you take integration, that omega is sent here and minus will be cancelled. Okay, if there are n number of electrons per cubic meter, then we have to take IE as then electron current IE as minus n E into V minus n E V, and substitute this velocity from here in this. Okay, this velocity here, then it becomes minus ne into E by m omega into em cos omega t. So that is nothing but minus n e square by m omega into em cos omega t. This minus indicates it is lagging behind electric field by 90 degrees. Okay, then this is nothing but inductive current. Okay, this, as we discussed, it becomes an inductive current. Okay, and the capacitive current becomes IC equal to d by dt of capital D. Capital D is nothing but K naught into E, and K naught is constant. If we take out K naught into d by dt of Em sin omega t. Okay, what is derivation of Em sin omega t? Sin omega t derivation is cos omega t into omega, and Em is constant. Therefore, IC becomes K naught Em cos omega t into omega. Okay, so total current is nothing but both when electrons are in motion as well as electrons not in motion. Okay, this current IC is when electrons are moving, and IE is when electrons are not moving. Okay, IC plus IE, K naught Em cos omega t into omega minus, since it is minus of IE value, okay, here this minus value we'll take here, minus ne square by m omega into Em cos omega t. When you take Em cos omega t into omega common, okay, this part common, K naught will be left in the first term, and in the second term ne square by m omega square. Okay, so take this K naught minus ne square by m omega square as K constant. Okay, then K equal to K naught minus ne square by m omega square. If you take K naught common, it becomes 1 minus ne square by m omega square K naught. Since you are taking K naught out, so here you should have a K naught. When you multiply this, K naught will be cancelled. Hence, the relative dielectric constant K with respect to vacuum or air is Kr equals to K by K naught. So which is K by K naught means, if you send this K naught to the LHS, it becomes K by K naught. That means 1 minus ne square by m omega square K naught. Okay, so the relative refractive index mu is nothing but root Kr. How we are getting this relation? Mu equal to root Kr is from this. Velocity is nothing but C by root Kr, which is C by mu. So when you take the equate this C by Kr and C by mu, mu is nothing but root Kr. Mu is root Kr. So therefore, if you substitute this Kr here inside the root, it becomes square root of 1 minus ne square by m omega square into K naught. As we discussed in the previous sessions, if you substitute all these constant values, you will be getting another formula, okay, where m is 9.107 into 10 power minus 31 kg, E is 1.602 into 10 power minus 18 coulombs, K naught equal to 8.854 into 10 power minus 12 farad per meter. We will be getting mu equal to square root of 1 minus 81 n by f square, where n is number of electrons per cubic meter and f is frequency. Okay, here in this ionization layer, if let us say more number of electrons are there, then this refractive index will be more decreased, because inside the root you can see here 1 minus 81 n by f square. If n is increased, what happens? This whole value will be increased, this fraction will be increased. Therefore 1 minus this fraction makes more decrement in the mu. Okay, more decrement in the mu value. So that is what today's derivation, very important. They asked for 5 marks. So please prepare well.